This is question number 1 in the non-calculator section. We're asked to evaluate, and we have a combination of mixed numbers and fractions. We have a subtraction and a division. So the rules of BODMAS tell us that the divide part is what we're going to have to do first. So currently we have 3/5 divided by 2 and 2/3. So we're going to do that before we do the subtraction. In order to do the division, what we will need to do first is change our mixed number 2 and 2/3 into a top-heavy fraction. So on the next line, we'll write that down as 1.5 take away 3/5 divided by, and 2 and 2/3 as a top-heavy fraction is going to be 8/3. So we get that by doing the whole number, 2 times 3 to get 6. Add the number on the top, which gives us 8. So our new numerator is 8 and the denominator remains the same at 3. So the rule for dividing with fractions is that we change the division into multiplication, and when we do that we must remember to flip the second fraction upside down. So that gives us 1.5 take away 3/5, and the division changes to a multiplication, and inverting the second fraction makes it 3/8. So we're now going to do our multiplication before we do our subtraction. So we have top times top and then bottom times bottom. So 3 times 3 gives us 9 on the top, and 5 times 8 gives us 40 on the bottom. So now we have 1.5 take away 9/40. What we want to do here is to subtract the fractions. Right now what they have is different denominators, so in order to subtract them we need to make sure that they have the same denominator. So if we multiply this one by 20 and then multiply the numerator by 20 also, then that will give us the same denominator of 40. So that's 1 and 20/40 subtract 9/40. So that's going to be 1 and 20/40 take away 9/40 is 11/40. The fraction part can't be simplified, so that's our final answer, 1 and 11/40. This is question number 2 in the non-calculator section. We're asked to expand and collect the like terms. So we have double brackets to multiply out, and we also have this extra term plus 10x. So dealing with the double brackets first of all, we want to multiply everything from the first bracket by everything in the second bracket. We'll do that one thing at a time. So we'll take the x from the first bracket and multiply it by the second bracket. And then we take the other thing from the first bracket, the -2, and multiply it by the second bracket. And then we can't forget the plus 10x tagged on here at the end for the time being. X times 3x, first of all, is 3x squared. Take away x times 4, which is 4x. -2 times 3x is -6x. And -2 times -4 gives us a positive. 2 4s are 8. And our plus 10x. What we want to do now is we want to collect the like terms together. So if we look along our terms, we have a -4x here, and then a -6x, and later on a positive 10x. We have 3x squared at the front, but no other x squared term, and we have our plus 8 in the middle somewhere as well, but no other single number term. This one, rather conveniently, the -4x and the -6x gives us -10x. So rather conveniently, I was about to say that will then cancel out with the plus 10x, -10x, add 10x, it gives us 0. So all of that will cancel out this. That leaves us with 3x squared plus 8, which is our final answer. This is question number 3 in the non-calculator paper. From age 7 to age 17, Billy's height increased by 50%. If Billy was 195 centimetres at age 17, how tall was Billy aged 7? So this is another example of a reversing the percentage change question. We want Billy's original height, which will be represented by 100%. His current height has increased by 50%, so that's then represented by 150%. So this gives his current height, which is 195 centimetres. We want to calculate his original height, which is represented by 100%. So we need a way of getting from 150 back to 100%. Going from 150% directly to 100% isn't easy to do. What we need to identify is a percentage we can work out that will be our stepping stone. A percentage which we can easily find by dividing 150, and then that percentage will then need to be easily able to be multiplied to go back to 100. So if we have a think about that, we should realise that the percentage we're going to try and find here is 50%. If we divide 150 by 3, then that gives us 50%. We can then multiply 50% by 2 to get back to 100. So if we divide on the left hand side by 3, then we must do the same on the right hand side. Now you might be able to do this in your head, but if you can't, we can set out a little bit of working at the side. So we're trying to do 195 divided by 3. So set this out in a division. 3 into 1 doesn't go, carry the 1 across. 3 into 19, well, 3 sixes are 18, so it goes 6 times, and 1 left over. Carry that on to the 5, gives us 15, and 3 into 15 goes 5 times. So 195 divided by 3 is 65. So 50% is 65 centimetres. We then multiply by 2 on both sides to get back to 100%, which represents Billy's original height, aged 7. So 65 times 2 is 130 centimetres. This is Billy's height, age 7, and that's the end of the question. This is question number 4 in the non-calculator section. We're asked to factorise fully. The first thing we need to know here is what the word factorise actually means. It means putting the brackets back in. So we've learned 3 different ways of factorising so far. The first of which is taking out the highest common factor. We've also learned about a difference of 2 squares and factorising a trinomial expression. Every factorising question should start with looking for the highest common factor, so that's how we're going to proceed. Looking at the 2 terms, 8m and 12m squared, we can see that the number 4 is the highest number that goes into 8 and 12, but also m goes into m and into m squared. That tells us then that our highest common factor, which sits outside a bracket, is going to be 4m. We'll put our negative sign in the middle. So now what we have to figure out is 4m times something in here has to give us 8m. So that's simply 4m times 2 in this case. And then 4m times something in here has to give us 12m squared. So that's going to be 4 times 3 makes 12, and m times another m to get the m squared. That's it factorised fully. There's no further factorising possible. So that's our final answer. This is question 4b and the second of our factorising questions. So like last time, the first thing we should do here is look for a highest common factor. But with the numbers 9 and 16, there is no number that goes into both of those. And then we have different letters, P and Q. So no common factor this time. So that means if we are to factorise, it must either be a difference of 2 squares or a trinomial expression. It should be fairly obvious that this one is a difference of 2 squares. The word difference means take away, and then we can quite clearly see our 2 squares. It's not quite ready to be factorised the way it is. because part of each term isn't in fact getting squared at the moment. So we need to make it something squared, take away something else squared. So that would be 3p all squared, take away 4q all squared. A difference of two squares requires double brackets. One of them gets a plus sign, the other one a minus. It's then just 3p and 4q in each bracket. That then completes our factorising by a difference of two squares and gives us our answer. This is question 4c and the third of our factorising questions. Predictably, this one is in fact a trinomial expression. The first thing we should always do though is check for the highest common factor. There is none. Our trinomial expressions factorise into double brackets, and the way that we normally do these ones is by setting out some working at the side where we have one bracket above the other bracket. So the first thing we want to look at is we want to look at the 2x squared. We need two things to multiply together to give us 2x squared. So that would be 2x and x. And then we go to the end, which is the number 5. So we now need two numbers that multiply to give us that. So that would be the numbers 1 and 5. 1 times 5 gives us the 5. Next we insert a cross here and multiply along the lines of the cross. So 2x times 5 gives us 10x and x times 1 gives us x. So these two things have to combine to give us the term in the middle, plus 9x, and the sign is important here. So what we want to do now is we want to put a sign in front of the 10x and in front of the x so that they combine by adding or subtracting to give us positive 9x. So you should realise that that means the 10 has to be positive and the x has to be negative. 10x take away x gives us the required 9x. So to get the 10x we multiplied the 2x by the 5. Since it's positive, that tells us that the 5 has to be positive. And then we multiplied the x times the 1 to give us negative x. So since that's negative, it tells us that the 1 also has to be negative. So if we don't get the correct numbers, or we get them the wrong way around first time, or whatever, then we just need to rub it out and start again. We have managed to get the correct numbers in the correct two brackets first time. So now we should write them down over here. 2x take away 1 in the first bracket and x plus 5 in the second bracket. That's our trinomial fully factorised, and that's the end of the question. This is question 5 in the non-calculator section. We are given a right angled triangle and we're asked to calculate the height of the triangle and to express your answer as a surd in its simplest form. So the height is this length over here. So what we'll do is we'll call that x. Now since it is a right angled triangle and we know the other two sides, that means we can use Pythagoras to work out x. So setting up Pythagoras, we have x squared equals, and then it's the long side squared, so that's 2 root 3 squared. Subtract the other short side squared, which is root 6 squared. So our next line of working is x squared equals, then squaring the 2 in here gives us 4, multiplied by, and the square of root 3 is just simply 3, take away, and then it's root 6 squared, which is just 6. So that's x squared equals 4 times 3, which is 12, take away 6. That then leaves us with x squared equals 6. And then to find x, we will have to square root, so x is the square root of 6. Now, this is a non-calculator question. The question asks us to express your answer as a surd in its simplest form. So we have a surd. Can it be simplified? Well, no, it can't. So that means that this is in fact our final answer. The height of the triangle is root 6. This is question number 6 in the non-calculator paper. We're asked to solve this equation. It has brackets in it, so the first thing that we will have to do is remove the brackets and then hopefully simplify. So we have 6 times p in the first bracket, which is 6p, plus, and then 6 times 2, which is 12. Then we have 3 times 4, which is 12 again, and then 3 times p, which is 3p. On the other side, we have 2 times p, which is 2p, plus, and then 2 times 6, which is 12, and then this negative 10 in at the end here. So we're looking for like terms now. You can see that we have 6p and negative 3p. So 6p take away 3p is 3p. Then we have positive 12 and add another 12, which gives us plus 24. And on the other side, well, we have our 2p first of all, with no other like term on that side. And then we have the numbers positive 12 and take away 10, which leaves us with plus 2. So the next thing we want to do is gather our numbers to the right hand side and the letters to the left hand side. So we're going to move a few of the terms across the equal sign. So this 2p is going to move to the left hand side, which means it will become negative 2p. And then positive 24 will move to the right hand side, which means it will become negative 24. So first of all, we already have 3p on this side. When the 2p comes over, as we said, it will be negative 2p. On this side, we already have the positive 2, which is just the same as 2. And when the positive 24 comes over, as we mentioned, it will become negative 24. So 3p take away 2p is just p. And then we have 2 take away 24, which is negative 22. So p equals negative 22. That's our final answer. Question number 7 in the non-calculator section. We're asked to rationalize the denominator. So the first thing we need to know is what that means. So the denominator, first of all, is the bottom of the fraction. And then it says rationalize. So that just means, in simple, plain English, get rid of the square root on the bottom. So our technique for doing that is to multiply the root 2 that we already have by another root 2. We don't want to change the value of the fraction, so if we put a root 2 on the top as well, then what we're doing is effectively multiplying by 1, because root 2 over root 2 gives us 1. So what that will do is it will get rid of the square root on the bottom, which is our aim. So on the top we have 8 times root 2, which is just simply 8 root 2. And on the bottom, well, we have this 3. And then we're going to multiply by root 2 times root 2, which you should know is just, in fact, 2. So that then gives us 8 root 2 over 3 times 2, which is 6. So now we have a fraction where there is no square root in the bottom, so we have rationalised the denominator. But what we need to do now, if we can simplify, we should go ahead and do that also. So the number 2 goes into 8 and into 6. It goes into 8 4 times, and it goes into 6 3 times. So that leaves us with 4 root 2 on our numerator and 3 on the denominator. So our fraction has the same value as the original fraction. It is equivalent, but we have managed to rationalise the denominator. That's our answer and the end of the question. This is question number 8 in the non-calculator section. We're asked to simplify, leaving your answer with positive indices. So we have p to the power of 4 multiplying a bracket. So the first thing we want to do is multiply the p to the power of 4 with the first term, 3p to the negative 4. So this p has a 1 in front, which means when we multiply it with this 3, it then just gives us 3. And it's going to be p to the power of something. So then we have a rule. When we are multiplying our indices, we add them together. So 4 add negative 4 is the same as 4 take away 4, which gives us p to the power of 0. Now the next thing we have to do is we multiply the p to the power of 4 by the fraction 2 over p cubed. So to make that a little bit easier, we'll put this over 1. So multiplying together, we have the two numerators, p to the power of 4 times 2, which is 2p to the power of 4. And then on the denominator, we have the 1 times p cubed, which is p cubed. So on our next line of working, we can start to simplify. The first thing we should realise is p to the power of 0, or anything to the power of 0 for that matter, is 1. So that then means 3 times 1. We then have the fraction to deal with. So that's in fact a division. So the answer is going to be 2p to the power of something. And the rule for division is we subtract the indices. So it's going to be 4, take away 3, which then gives us 1. So the next line, 3 times 1 is 3. Take away 2p to the power of 1, which is just written as 2p. That's our final answer and the end of the question. This is question 8b in the non-calculator section. Again, we have an indices question where we have to multiply out a bracket. So we've got 4d to the power of a half, and it's multiplying the bracket which contains 3d to the power 3 over 2, take away d to the power negative a half. So the same rules apply as before. When we are multiplying, we add the indices. So let's move this over a little bit. So the first thing we're going to do is multiply our 4d to the power of a half by 3d to the power 3 over 2. So the 4 times 3 is 12, and then it's going to be d to the power of something. So what we'll do is we'll set a section off at the side to do a little bit of working. So our first power is a half, and we're going to add 3 over 2. So that's simple enough since they have the same denominator. It then gives us 4 over 2, and 4 divided by 2 is in fact just 2. So our first power is d squared. Then we're going to subtract, and then it's 4d to the power of a half multiplied by d to the power negative a half. So now that will give us 4d to the power of something, and that something is what we're going to work out again over here at the side. So the first power is a half, and we are adding the powers, and this time we are adding negative a half. So when you add a negative, it's a subtract, so it's a half take away a half, which then just leaves us with 0. So our power on the d is 0. That then gives us 12d squared, take away 4 multiplied by d to the power of 0, anything to the power of 0 is 1. So that then becomes 12d squared, take away 4. That's our final answer and the end of the question. This is question number 9 in the calculator section of the homework. In 1999, the city of Venice was visited by 16 million tourists. In 2000 to 2002, the number of tourists fell at a rate of 3.5% per annum. And then from 2003 to 2005, the number of tourists rose at a rate of 6.8% per annum. Calculate the number of tourists who visited Venice in 2005. So the first thing we want to start with here is our initial figure, which is 16 million tourists. We are told that the number of tourists fell over a 2-year period at a rate of 3.5% per annum. So if we subtract 3.5 from 100, we get 96.5, and writing that as a decimal is 0.965. It was a 2-year period, so that means we are going to work that out to the power of 2. We can then do this step on a calculator, which gives us a figure of 14,899,600 tourists by the end of 2002. We are then told that the tourist population rises again at a rate of 6.8% per annum over the next 2 years to 2005. Our start point this time is the figure from the end of 2002, 14,899,600. This tourist population increases at a rate of 6.8%. So adding that onto 100 gives us 106.8%. and as in a decimal that would be 1.068. Again, it rises over a 2-year period, so we can do this step once more on our calculator, which gives us our answer for the number of tourists in 2005. So from our calculator we get 16,994,841.4. So if we then approximate that value, we can say that the number of tourists visiting Venice in 2005 is 17 million. That's our answer and the end of the question. This is question number 10 in the calculator section. We're asked to calculate the gradient of the line passing through each pair of points. Simplify each fraction where possible. So first of all, in part A, we have the points D and E. Let's make this a little bit bigger. So in order to work out the gradient of the line joining these points, we should use the gradient formula. So that's m equals y2 take away y1 divided by x2 take away x1. So these values come from the 2 points. This is our first point, so that's our x and y value, x1 and y1 since it's the first point, and our second point, x and y again, this time x2 and y2 since it's the second point. So substituting into the formula, y2 is 6 and we're subtracting y1, which is -2, so careful with the signs there. And then it's x2, which is -8, and once again we're taking away, and it's x1, which is 3. So on the top line we have 6 take away -2, which is the same as 6 plus 2, which is 8, over -8 take away 3, which is -11. So we have a fraction which can't be simplified. It's 8 over 11 and it's negative, so we'll put the negative to the front, leaving us with our final answer. Question 10b, we're given another pair of points and we're asked to work out the gradient of the line joining the 2 points. So once again, we have our x and y value for each point. This is x1 and y1 and x2 and y2. Substituting into the gradient formula, m equals y2 minus y1 over x2 take away x1. So substituting our values in, y2 is 20, subtract y1 which is 10, over x2 which is 15, take away x1 which is 5. So in the numerator we have 20 take away 10, which is 10, and then on the denominator 15 take away 5, which is also 10. That leaves us with 10 over 10, which just gives us 1. So the gradient of the line joining these 2 points is 1. This is question number 11 in the calculator section. A boy is in the shape of a hemisphere with a cone on top as shown opposite. So there's our hemisphere, our half sphere down at the bottom. Then we have our cone shape on top. We're asked to calculate the volume of the boy and give our answer correct to 3 significant figures. Now in order to find the volume of this composite shape, we'll have to work out the volume of both parts separately. So first of all we have our cone shape, which I will mark out in green. So the volume of the cone V is equal to 1/3 times pi times the radius squared times the height. So in order to work this out, we will need to know the radius of the cone and the height of the cone. So first of all, if we look to the bottom, we have this measurement here, which is 70 centimetres. Now that's clearly the same as this distance here, which is the diameter of the base of the cone. That means that the radius of the cone is going to be half of 70, which will be 35. So now the height of the cone, which is the distance going from here to here, it's a bit trickier. It's not 105 centimetres, because that's the height from the top of the boy all the way down to the bottom. Now that can be split into two parts as shown here, this blue part from here to here, and then the purple part from here to here. Now the blue part is quite clearly the height of the cone, and this purple part we have to realise is in fact the radius of the hemisphere. So earlier on we talked about the diameter of the hemisphere, this horizontal distance being 70. So we spoke about the radius then being 35. So we need to remember the radius can be measured vertically also, which means the purple line is 35. If the purple line is 35, then that means the blue line is 105, take away 35, which means the height of the cone is 70. So substituting those values into our formula gives us 1/3 times pi multiplied by the radius squared, so that's 35 squared, multiplied by the blue height, which we worked out was 70. So we can now put this into a calculator to work out the volume of the cone part, which gives us 89,797, and that's cubic centimetres. That's the cone part dealt with. The next thing we need to look at is the hemisphere. So I'll mark that out here in yellow. A hemisphere is basically half of a sphere. So the volume for a sphere, first of all, is V equals 4/3 pi r cubed. So this time we just need to know the radius. So again, if we look at our diagram, we can see that the radius of the sphere is the same as the radius of the cone. So again, it's 35 centimetres. We are looking for the volume of a hemisphere, so that's going to be V equals 4/3 pi r cubed divided by 2. Substituting in our values, we have V equals, let's just move this up a little bit, and that's 4/3 multiplied by pi times 35 cubed, and then all of that divided by 2. So we can do that on our calculator, which gives us a volume of 89,797, which coincidentally is the exact same volume as the cone part. So what we want to do now is add these two together. So we'll give ourselves a little bit of room by moving this over to the side. So that's 89,797 plus 89,797, giving us an answer of 179,594. Now, if we remember the wording of the question, it asked us to give our answer correct to 3 significant figures. So that's the 3 most important digits, the first 3 at the left hand side, the 1, the 7 and the 9. Because the number beside the 9 is a 5, then that means we're going to round the 9 up, so it will be 180. So we have 180 and then 3 zeros to hold the place. That then gives us our answer correct to 3 significant figures, which is 180,000 cubic centimetres. That's our answer and the end of the question. This is question number 12 and the last one in the calculator section. A test tube contains 3 times 10 to the power of 4 cubic millimetres of water. If each cubic millimetre of water contains 1.75 times 10 to the power of 3 bacteria, how many bacteria are in the test tube? Give your answer in scientific notation. So in order to work this out, we'll need to multiply those two numbers together. So 3 times 10 to the power of 4 multiplied by 1.75 times 10 to the power of 3. So we can easily do that on our calculator, which then gives us an answer of 52,500,000. The question asks us to give our answer in scientific notation. So this is a whole number, which means the decimal point is over here in this position. We need to move the decimal point to write it in scientific notation. So that's once, twice, 3 times, 4, 5, 6, 7 times to make the decimal point end up in here. That gives us our answer, which will be 5.25 times 10 to the power of 7 bacteria. That's our final answer and the end of the question.